Hello, my name is Miguel Almeida and I work at ADAI from the University of Coimbra in Portugal. I will introduce this topic of natural fuels that exist in the immediate vicinity of houses and that can contribute decisively to increasing the fire risk. Particularly in rural areas, houses usually have several types of natural fuels in their vicinity, as we can see in these images. Some of these fuels increase the fire risk, but others mitigate the fire risk, being an obstacle to the passage of firebrands that could set the house on fire. In this example, from the large fires, we have this house, and the owner of the house says that the house was saved from a rain of firebrands that was observed, and was saved because of this tree. So the crown of these tile trees was an obstacle to that rain of firebrands, and so the house was saved. In any case, in this presentation, I will focus on fuels that increase the fire risk. And there are several examples that can be given, such as nests on the roofs, or dirt on the gutters, or the existence of firewood near houses, as we can see in here. There are, of course, other elements associated with the construction of buildings or the gardens. And among these elements of risk, we highlight edges that are often the border of properties, and so within the gardens. This presentation focus essentially on edges and as an element of potential risk. And there are several factors that make edges more or less susceptible to the increasing of fire risk. One of these factors is the type of vegetation that is used. Usually, broadleaf species present a lower fire risk. Besides the chemical characteristics and the higher moisture content of the broadleaf species, the greater combustibility of the vegetation used in the edges are largely due to the tendency of plants to accumulate dry and dead material inside, as we will see later. In respect of that, we can say that the pruning to which edges are often subjected plays a fundamental role. Notice these two images, which represent two edges composed of the same vegetation, of the same species. In this figure above, the plants have been pruned, and a large amount of dry material can be seen inside. What happened was that the surface pruning stimulated the tips of these surface branches, as we can see in here, which drove to several leaves to grow on the periphery of the edge. This outer layer of leaves created shedding conditions, which prevents the survival of the inner leaves. In some species, the inner leaves fall down, and so we do not have so much dry material inside, while in the other species, the dead material is kept inside the vegetation. Of course, that the availability of water is also a very important factor in the flammability and combustibility of edges. Again, the tendency of plants to keep the material dry or to drop it into the ground, the dead material, plays an important role in the fire risk. To better understand how edges behave in fires, we carried out several laboratory tests with 4 species, so the Cupressus arizonica, the Cupressum paris leylandi, the Thuja occidentalis, and the Prunus laurocerasus. This study had 2 phases. So the first phase concerns the characterization of the species that were tested, and the second phase consisted of burning tests with isolated trees or with a line of tea trees constituting a small edge. In both phases, fresh or green plants were used, as well as separately partial dried trees that were in absence of water during several days. We also note that the trees used were not adult trees. Thus, we start by characterize the plants in terms of dimensions and separate each individual in 3 layers, top, middle, and base, which allowed us to characterize each of these layers in terms of moisture content, type of material, from fine material to coarse material, and the mass distribution. In this table, we have the results of this characterization. Of course, I don't want that you read all these values, but I would like to point out that Cupressus arizonica and Thuja occidentalis were the 2 species with lowest moisture content. Regarding to the dry material fraction, which, as we have seen, is of extreme importance. Cupressus arizonica was clearly the species that showed more dry material, while in the opposite direction is the Thuja occidentalis with, let's say, more fresh material, more green material. Regarding to the burning tests, as I mentioned, we have done tests for different species, for different states of water stress, going, as you can see in here, from 5 days to more than 3 months without water. These tests were carried out on the tree burning platform of our fire study laboratory. So the trees were supported on this platform where we can measure the mass decay, the mass loss. And the ignition was made simultaneously using alcohol containers that were supported on a structure that did not contact the platform and consequently did not interfere with the mass loss. Here I show you the experimental apparatus where we can see that the mass was measured, as well as the radiation total and the radiative heat flux, then the airflow velocity and the thermocouple in the top of the tree. And we also capture images in order to analyze the dimensions of the flame. We also use a PIV system to characterize the particles that were released, the firebrands, but it's not presented in this. So the sequence of the tests start, therefore, with the measurement of the characteristics and the installation of the trees, the placement of the trays with the denatured alcohol, and then the ignition. And the tests were only considered to be finished when there was no more flame combustions of the plant. Moving on the results, we will start with the mass loss. It can be seen that species such as the Thuja occidentalis have burned much faster than, for example, the Prunus laurocerasus. In here, up here, we can see the absolute values, while below we have the relative values. We have converted this decay zone to an exponential model with the control of the parameter k that represents the mass loss coefficient. This table resumes the several mass loss coefficient for all the experiments performed. I would like to highlight the worst response to water stress from the Cupressus arizonica and the good reaction that was observed for the Prunus laurocerasus. These results are similar for both for trials with a single species or for sets of three trees. What happened with the water stress that we can see the difference between these two species is what I mentioned before. So the dry material in Prunus laurocerasus fall down to the ground, while the Cupressus arizonica kept the dry material attached, which then participated in the burning, increasing the fire intensity. The same conclusions can be drawn from the analysis of the total heat flow flux. At the top we have the total flux, and at the bottom we have this relative flux. We can see that for fresh plants the results are quite similar. As we can see, there are no big difference between the species. But with the water stress, we can see larger differences. So with the Prunus laurocerasus showing better fire behavior, and species like the Cupressus arizonica or here the Tui occidentalis increase the fire intensity with the water stress. In the analysis of the size of the flames produced, we considered the area of the flame, or this area, and also the flame height. It can be seen here that the results are consistent with the previous discussion. So at an early stage, the results are are similar for the different species, but with the water stress, the combustibility values for Cupressus arizonica and Tui occidentalis are extreme, while for the Prunus laurocerasus the flames produced are much smaller, as we can see. To conclude, we state that the existence of natural fuels close to buildings is a factor that greatly increases the fire risk. The presence of edges in the vicinity of houses increase also the fire risk. The choice and maintenance of the species composing the edges allow to mitigate their weight as a factor of fire risk. The species such as Prunus laurocerasus are more favorable in terms of fire risk when compared to other species, especially the Cupressus arizonica. We also stated that the loss of moisture in plants increase the fire risk. However, this effect is much more evident in species such as the Cupressus arizonica and less evident in Prunus laurocerasus. The presence of dry material inside the edge contributes decisively to its propensity to sustain the fire. And the fraction of dry material inside the edge varies according to the species and increases with the pruning or the trimming. And that's all. Thank you very much for your interest and for your attention. Please, if you have any doubts or something that you want to discuss, you can send me an email, or you also can visit the website of the project, and we will have the address to contact with us. Thank you and goodbye.